Alright guys, we need to remember how to find equations from 2 points. We always want to get equations in the form y equals mx plus b. I'm going to use my formula change in y over change in x, which is the same as y2 minus y1 over x2 minus x1. Let's do an example. Alright, let's look at our first example. Line A passes through the points 0, 2, and 2, 6. Line B passes through the points 3, 0, and negative 3, 4. Find the equations. Obviously, this is going to end up being a systems. I'm going to treat each one of these individually. The first thing I'm going to do is pull out the coordinates from my first line. 0, 2, 2, 6. Now, the next thing I'm going to do is go ahead and label them. This is my first x value, so it goes x1. Second x value, x2. First y value gets a y1, second y value gets a y2. Now I'm going to recall my equation. y2 minus y1 over x2 minus x1. This is just like our tables. So I have 6 minus 2. Again, I just got those numbers from here. This is my y2 value, so it goes here. Minus our y1 value, which is 2. Next I'm going to plug in my x values. 2 minus 0. Now, 6 minus 2 is 4. 2 minus 0 is 2. 4 divided by 2 is 2. What I just found was my slope. What I need to do now is figure out what b is, or what my y-intercept is. So again, I have y equals mx plus b. I already know what m is because I just found it. M is going to be 2. The way I figure out b is by taking values from either my first set of coordinates or my second one and plugging them in to figure out what b is. So I'm just going to choose to do our first set of first coordinates. So I already know what y is. Our y value here is 2, so I'm going to plug that in for our equation. 2 equals, we already know what m was. M was our slope. 2 pocket, because a value is going to go in there, and that value is going to be 0 plus b. Now, 2 times 0 is 0, so I'm just left with 2 equals b. So now that I have my m and my b, I can go ahead and plug those in and write my equation. Y equals 2x plus 2. And that is our equation for line A. Let's do line B. All right, let's find the equation for line B. First thing I'm going to do, pull out, whoops, let's make that smaller. Pull out my coordinates and label them, just so I can keep track of everything. This is x1, x2, y1, y2. Now again, m equals y2 minus y1. We use this formula to get our slope, over x2 minus x1. So it's going to be 4 minus 0 over negative 3 minus 3. If I do that, 4 minus 0 is 4. Negative 3 minus 3 is the keep, change. Negative 3 plus negative 3 is negative 6. If I reduce that down by dividing by 2, I'm going to have a slope here of negative 2/3. So now that I have my slope, I need to figure out what my y-intercept is. All right, my next step is just to plug in my slope into my formula. So I have y equals mx plus b. I already know what m is. I'm going to plug that in, and I'm also going to plug in values for x and y. Again, I'm going to choose my first set of coordinates and just solve it out. So 0 is going to go in for y. I have a slope of negative 2/3 times our x value of 3 plus b. Now, if I solve this out, negative 2 times 3, we're going to put that over 1, make it easy. Negative 2 times 3 is 6. Negative 6, and 3 times 1 is 3. So I'm going to have negative 6 over 3, which reduces down to 2. So now I have 0 equals 2 plus b. If I subtract 2 to both sides, I find that b equals -2. So the equation for line B is y equals -2/3 x minus 2. Now, without even looking or graphing or solving these equations, I can look and see that their y-intercepts are different, which means that this solution set is going to have if our y-intercepts are different and our slopes are different, the number of solutions for the systems will likely be 1. I could graph it and prove it, or, oops, sorry, I didn't mean to write that, guys. I could graph it and prove it, or I could solve it out and prove it that way. All right, that's going to be it for me today. Let's go ahead and practice.